Hello guys, this is the fastest revision video of plant design and economics, and this is meant for revision purpose. So I won't cover much in detail, but it is the fastest revision, so a better kind of revision. So let's start. So subscribe and like the video if you really like these videos. So first is that the PBT, so profit before tax. This is nothing but the net revenue. So the net revenue minus the net cost. Okay, so like total income minus total cost, that is profit before tax. Now if we want to add this tax, for that we first do PBT minus depreciation. So R net minus C net minus depreciation, and we calculate tax on this amount. Okay, one more thing is to be look at this. This is TCI, so total capital investment is FCI plus WCI. Fixed capital investment and working capital investment, this is one time at the starting, and working capital investment is also at the start, but this could be used for emergency purpose. Okay, and there is land. So land is a non-depreciable capital investment. Next we have the taxable profit. So the taxable profit is nothing but the R net minus C minus D. This is the whole, or we can say PBT minus D. This is a taxable profit, and after applying tax, so we have profit after tax. So let's say tax paid is something, say T. So from total the taxable profit, this is taxable profit. From taxable profit we minus the tax paid. This is the profit after tax, and this tax paid is equal to tax percentage into the taxable profit. Okay, and the net cash flow is annual basis, yearly basis. So the net cash flow will be nothing but the profit after tax plus the depreciation. Now let's move to the ROR, rate of return or return on investment. This is profit, the total profit divided by in yearly basis. Okay, divided by investment, the net investment, that could be the FCI. Okay, so profit divided by investment. And next we have in the profit here, it is mostly PBT. Okay, PBT means profit before tax, if there is no tax. And then we have the payback period. Payback is nothing, payback, it is actually time. So it is the investment upon the cash flow. This is the payback time. Now one important thing is the rate. So we know compounding is like this: P plus I is the rate, the annual rate of the percentage, the interest, and P plus I to the power n is a general formula. But what if we have monthly? So in case we have monthly, just remember that in case it is monthly or any quarterly or anything, so divide this I by the division. Like let's say it's monthly, so it would be 12. Okay, but I'm taking this a general case, whatever it is, quarterly or something, divide it with whatever the whole year is divided. So let's take M. Okay, the whole year is divided into M parts, so rate of interest divided by M, and multiply here. So divide and multiply M here and here. This is a thing that you should remember. And 1 plus I effective. Okay, if I do this, 1 plus I effective, and here also P 1 plus I M. Some people also take this R. It is absolutely fine. I hope you understand that it's just notation, into N M. So PP cancel. So 1 plus I effective is nothing but 1 plus I by this is M, I by M to the power M. This way you can find out I effective, and it is asked in the question. Also, if it is continuous means it's not discrete, so we would put limit over that I effective 1, and finally it would arrive. So if the m is infinite, that means it's continuous, no discrete places, then finally we will get the e to the power r or I. This would be our I effective. Okay, e to the power r. In fact, this is 1 plus I effective. This will be e to the power I or r. Okay, so next thing is the future value. For anything, if you want to take the future value, the formula is pretty simple. Let's say future value is s. Okay, then it is the annual or the monthly. It could be monthly, or let's take annual. So it is the annual investment. Okay, plus into this to the power n. Okay, now this is the investment that is compounded, and then it is for the future value. What we do is that we take it divided by I and minus 1. So the compounded thing only, but just the minus 1 and divide it with I. Okay, this is the yearly investment to the future. Okay, so r yearly sum to the future. So this s is the future, while the present value, to get the present value of a future amount, so future and present, and this is the plant operation years, plant life. Okay, we know the future value is this s. R, if r was invested like this, so it was s 1 plus I to the power n minus 1. This is n. Okay, divided by I. And for the present, what we do is we take this 2 back. So present means, let's say t 1 plus I to the power n minus 1 divided by same thing, just divided by 1 plus I to the power n. This is the present. Okay, next let's look at, so if it is quarterly, then m will be 4. Okay, that's also one thing. Next, capitalized cost. It is some cost added to the value. Let's say this is C naught plus V naught. V naught is the initial value of the plant. Okay, and C naught is something that is added to, so that it would get interest. Okay, let's say this is our plant, and maintenance is RRR going on till the end. Okay, RR is maintenance cost. We add V naught. V naught is the equipment cost, and finally it will end to V salvage. Okay, and this V naught, we add some extra C naught, so that it could pay all these maintenance costs in the future, because this will also grow. Okay, this is how the total is capitalized cost is C naught plus V naught. Okay, let's revise it fast. So C naught, let me derive it in a quick way. C naught 1 plus I to the power n minus 1. This is C naught compounded minus 1, because C naught is also invested in the starting. This is the investment that would take care of the final investment of the net value of the operated plant or vessel, anything. Okay, plus the R, the maintenance would be yearly, so we will take its future value, because all this thing is finally calculated on future basis. Why? Because at the future we can get this S, so we can minus this as V salvage value. Okay, so this is the whole formula, and let me write it in a total way. So finally you can find out this C naught as some expression. Okay, let me write the expression. V naught minus Vs divided by 1 plus I to the power n minus 1 plus R upon I. Okay, this is C naught, and with C naught, if we add V naught, it is capitalized cost. Okay, so this is how we can compare. Okay, next is let me show you some trick to solve some question. Like in some question there will be rupees per year, let's say, and some kilogram, so some year by, or let's say in this year, these years are taken for this kilogram process. So in some questions like this, like it will be like a word problem, like in units needs to be matched. That is a very good trick, that if you match up the units, so you can cancel this and you can find out, because answer would be required in like how much rupees per kilogram is actually produced. So try to match the units, cancel the units some way, and you can get them. Okay, these questions you will find might come. So this is how units are important. It's just a trick that helps sometimes. Now let's say break even point. Okay, break even point is when the profit, so break even point is when the profit, the net profit, summation of profit is the summation of cost, and here cost plus the FCI of cost. Okay, the initial investment. So profit is cost plus FCI. This is how you can calculate break even point. And if profit is selling price into number of units, cost is cost price into number of units plus FCI. So sometimes you need to even find this n. Okay, this is how you can find it. And if you want to just minimize the cost, or you can take this minus, this whole term is the profit, and if you want to maximize the profit, then d of this whole term upon this n, for how many years this will maximum. This way you can actually find out, or some way like that, differentiation equal to 0. So d of that whole upon, let's say, n or something equal to 0. That's how you can maximize or minimize. Okay, that was break even point. Now let's move to very important thing, NPV, net present value. That is there's also like this chart. Okay, so at the starting the net present value is negative, because we at the starting, at year 0, we invest, and slowly as the plant moves, we get our profits, and this is when a net profit is 0. So this is the break even point. Okay, this is the break even point. Or it is also the payback period, because we get whatever we have invested, we from our profits we repay it back. So profits is net of that cost plus this. Now if the IRR, let's talk about first the NPV. So NPV is FCI, so minus of FCI, because it is invested, plus we have the cash flows, and cash flows discounted value, because everything this is present. Okay, this is present. Present means here at t is equal to 0, so the initial start we have invested this. See, cash flows we will get of different years divided by 1 plus I to the power n. Here n refers to like first year, second year, third year. So if it is like cash flow 1, so this is 1, cash flow 2, this is 2, and so on. Okay, and finally at the end we will also get this VS, salvage value. Okay, and this is TCI, and then we have the working capital in investment also. So salvage value to the power n is the lifetime. This is something we also get towards the end, we bring it to the present value, plus we get the working capital index also, that we bring to the present value. Present value means t is equal to 0, so we divided by 1 plus I to the power. These two things we get at the end. So if someone says NPV till first year or second year, this will not come. This will come when it's the end of the whole cycle of the whole life of the plant, because at the end only we sell the salvage thing, the remaining equipment, and the working capital investment is finally comes into the treasury. So now what is IRR? IRR is internal rate of return, that would be some I percent corresponding to NPV is equal to 0. Just that expression I have written over that, put that it equal to 0, and if I is unknown, we can find I. So this is the internal rate of return. So this is internal rate of return. So if my this IRR percentage is high, that definitely means that our return percentage is high, so it is a better project. IRR should is preferred. Now cost index is like cost of some equipment in year 1990, cost of some equipment, this is example, in 2000. These are example years, so nothing but it is cost index of 1990 by cost index of 2000. So basically cost of the equipment or anything is proportional to the cost index at that year, in the same year. Proportionality. While for quantity, if something quantity comes, so it's 6/10 rule. Okay, I once got 6 out of 10 in my SST social studies, so you can remember that way, that is 6 out of 10. Okay, jokes apart. Okay, 6 out of 10. Don't worry, I got 10 later on, but let's move on. So cost is proportional to the capacity to the power 0.6. Okay, so this 0.6, that means 6 upon 10, that is cost. This is proportionality to capacity 6 power 10. Okay, now let's move to Lang multiplier factor. This is for the, if a equipment is delivered, so it is delivery, some added cost to this delivery cost. Okay, this factor is introduced, so the deliver cost into Lang multiplier factor is the final cost of the whole equipment. So this factor is for different. So for solid, let me write solid liquid operation, solid liquid, and liquid. The table is like this. Okay, I will tell you some easy way to learn. First write 4, add 0.4 and write here 5, 4, 5 and write here 6. Okay, now if this is increasing 4 point something, 5, and this 5 here, make it 5 like this. Okay, this is 6. Okay, 4, 5, 6 and 4 point. So 4 point something, I will tell you 5 and 6. This way Lang multiplication factor. Then something that adds up to 10. So put this 3, this is 7, so 7 plus 3 is 10. That way, some way you can remember. Okay, so this is the Lang multiplier fact, that. Okay, and now let's move to the depreciation, very important part. We have various methods. The first is very simple, the SLM, straight line method, which is nothing, just straight line, that the D is nothing but V0 minus Vs, initial minus salvage value, upon N. N is the total lifetime of the life cycle. Then this is first. Second is declining balance method. Declining balance method is VA. So at any year A, what will happen? V0 to the power some decreasing factor, raised to the power A. Okay, to the power some decreasing factor raised to power A. And now this decreasing factor, this is 1 minus F. Okay, so this F, 1 minus F is that decreasing factor. F is in percentage. Okay, and this is how you do. So what would be VS? VS salvage would be the decreasing factor at the end, so N would become. This is how you can actually find F in some questions and then put it and get this. But in DBM, the declining balance method, how to find the depreciation? Depreciation in the DBM is nothing but V previous year. Okay, so let's say V previous year into F. Let's say V0. Okay, V1, V2. this dA with D would be on the basis of V naught, so the previous year, okay, like this year, because what will happen, previous year into F, so this part, then this part, this way. I hope you get it, because if this is A, D1, then this is the minus of this V naught into F. So after minusing, we get the value. So VA we will get, and from VA we again find out the depreciation for the next year. Now if it is sometimes double DBM, double declining balance method, let me explain it very fast. Same, what do? Do SLM first, okay? Do SLM, okay? You will find some depreciation, okay? Basically this depreciation, what we do is do this, some depreciation percent is find the DSLM divided by V naught, okay? So what is this actually? Basically it is DSLM is V naught minus VS upon N divided by V naught. So basically you are calculating this some D percentage, okay? And when you get this D percentage, just multiply it with 2 and this is your F. You get your F. So first calculate DSLM and then DSLM divided by this V naught, and this will be D percent, multiply by 2 because double declining balance, and this would be F. So after you get F, just apply DBM, declining balance method. So first D from SLM, DSLM, D percent, multiply by 2 because this is double, F, we had get F, and now the declining balance method as it is, okay? Now the sum of digits method, okay? This is like DA, so remember this way, N minus A, the difference, how much year is left, okay? How much year is left, minus 1, or sorry, plus 1, minus plus, okay? So how much year is left plus the first year plus the year itself divided by the sum of n natural numbers, okay? Write it like this, and sum of n natural number we know is n plus 1 by 2, and here this is just a thing into the V naught minus VS. So this thing is like, for if we compare it with SLM, it is like 1 by n, so this is DSLM, but in case of that we use this thing, okay? N minus A, how much year is left in sum of digits year method, how much year is left plus the year of the A itself divided by the sum of n natural numbers. This is how you find this. And again in here, if we want to find the V2, it is V naught minus the depreciation of first year minus the depreciation of second year. This is how you calculate. There is no F here, okay? You need to calculate individual depreciation by that and minus them, okay? Now sinking fund, nahi yaar डूब गई. So sinking fund method, what will happen? Your fund will sink, that means it will decrease, okay? Why? Because your depreciation with time will increase while your fund is decreasing because your depreciation is increasing. So first year let's say the depreciation is D, second year the depreciation is 1 plus I, D into, it is compounded, third year it is again compounded to the power 2, okay? And this way finally for the like n year, n minus 1. This is how your depreciation will slowly increase. So at the final, your total depreciation would be the whole compounding of this, the future value. So this is the future value if D is coming, and finally this and this, no, this thing by I, and this is nothing but V naught minus VS. this is the total depreciation, and finally this is v0 minus vs, because we have to, we use, why do we do depreciation, is to just recover this loss of value in the equipment or the plant. This was the economics part. Let's for the design part. Let's say we have a cylinder and the thickness, this thickness of this shell is t p d naught, okay, outer diameter divided by 2fj plus p. Again, p is the pressure, okay, and d naught, f is some factor, okay, it will be given. J is also some factor, it will be also given. F is the stress actually, no, F is the stress, J is some factor, and P, okay. So and next thing is that the sigma, the circumference, the stress here for the let me tell you this in this way, that this circumferential stress, okay, the circumferential stress this way is twice the longitudinal stress. This is something you need to remember, okay. There are formulas, derivation, but circumferential stress is twice the longitudinal stress. And finally the heat exchanger. If I say heat exchanger, so the D equivalent is equal to pitch square minus the area divided by the area, okay, this square, and this is for square pitch into this whole area upon area, this is a fraction, into the diameter of the tube. And for triangular pitch, it is 0.86, okay, pt square minus pi by 4, again the area pi by 4 d naught whole square by pi by 4 d naught whole square, but remember it is 0.86 is some added factor over here, into this d naught. So these were all the formulas. Let me just give you some thing, tell you, because then it will look like I'm running away. So this is there, okay, this is, so my pitch is the distance between these two, okay, square pitch, so pitch whole square, this whole area minus these areas, okay, minus this area, this is the flow area, again this flow area, so pt square, because square, minus the whole circle's area divided by a whole circle's area, if the circle is between, okay, so divided by whole circle area is the ratio that I told you previously into the d naught of the tube. So I hope you like this video. Please like, share and subscribe, and I will bring more revision videos further.